Well, good morning, everyone, and welcome. Thank you for joining Elevator U's webinar this morning. My name is Eddie Morse. I am the Elevator U president and the Elevator program manager with the University of Virginia. And we have Kevin Morse and Dale Hughes this morning. They're going to do a presentation on elevator design specification guidelines, and we will have questions, and there's a questions and answer box at the bottom of your page. And let me make sure I'm telling you right, be to the left of chat. And so there will be a time, this presentation is probably going to take about 25 or 30 minutes. After the presentation, we'll be open for questions. So if you have any questions, you can put them in that questions and answers chat box. Brad will be moderating, and he can ask those questions for Dale and Kevin to answer at the end. This presentation will be on demand on the Elevator U website, elevatoru.org, maybe within a week or less after today's presentation. So you can go back and visit that for your own time, later on. With that being said, I'm going to turn it over to Kevin and Dale.
Okay, thank you, Eddie. My name is Kevin Morse. Like Dale mentioned, Dale and I will be presenting this new guide. We were asked to, the Elevator U Education Committee was working on developing a guide for criteria and specifications for recommendations for colleges and universities for a while. Dale and I, while we were still with Naval Facilities Engineering Command, we presented on the elevator design criteria and specifications that we had developed for NAVFAC, for Navy and Marine Corps installations. And we presented our ideas and what we had developed for criteria and specifications. So then we were asked to prepare something for Elevator U, and this is the result of that effort, working with some of the other folks on the education committee, and that's what we'll be presenting today. I'm going to scroll down to the introduction page. We're assuming there's a lot of material to cover here. So we're making an assumption that most of the people that are on the webinar, attending the webinar, are familiar with Elevator U and familiar with elevator systems and elevator design. So we're going to focus on specific items in here for the presentation, but anything that you see in here that you'd like to ask questions on, you'll be able to do that in about 30 minutes. So what you see highlighted, the Elevator U Guide for Development of Criterion Specs is a compilation of systems and components. The guide provides recommendations for system and component designs that maximize life cycle cost and maximize performance, service life, and energy efficiency. Dale and I, if you read our bios, we have about 45 years of experience each in the elevator industry as elevator mechanics, as certified elevator inspectors, and then managing the elevator program for Naval Facilities Engineering Command. So what our ideas, our proposals, and what you see in this is a result of what we've seen over the years that seems to be in the best interest of the building owner. The purpose of this guide is to primarily elicit ideas and discussion and promote elevator education. So we're going to go right into chapter 2 is general design considerations. Everybody knows, we're assuming everyone is familiar with freight elevators, passenger elevators. Most of you should be aware of requirements for emergency medical services accessibility. Building code requires that accessibility where elevators are provided in the buildings 4 or more stories. What we recognized at NAFAC was that even in a 2-story building, it can be difficult and hazardous to emergency service personnel and to the people that they are trying to transport out of the building to carry somebody down the stairs on a stretcher. So what NAFAC did was to say every building, every multi-story building, if it's 2-stop or 10-stop, must have one elevator that is designed for emergency medical service accessibility. So that's what you see in 2.2 here, and the recommendation. So that's the thing. This is recommendations. This is not, you must, every college and university must do this. It's recommendations. Facility management should consider EMS accessibility for a minimum of 1 elevator, regardless of the number of stories in the building. Uh, 2-3 is standby and emergency power. A17.1 and IBC don't require emergency power, but it does have specific requirements in the case of where emergency power or is provided in the building. What I highlighted here, so you have emergency standby power design requirements, and this is just information to the designer and to the facility manager of what to think about when you're designing or renovating a building. In 2-3.2, the part I highlighted here, for buildings that are not required to have all the elevators operate on emergency or standby power, the following recommendations should be considered to provide a minimum level of safety for building occupants and emergency responders. One of them is sequential operation. So if you don't have the power to run all the elevators at one time, the elevator controllers are designed for sequential operation to bring one elevator down at a time. And we've run into this situation. This is an area for anyone who works in or supports design for new construction and modernization. This is easily overlooked in that design process. So you have to ask that question at the very beginning of the design process. Ask the building owner or what they expect to have. What are their expectations? What do they need? Do they need all the elevators to run at the same time, or is running one elevator sufficient with sequential operation to bring them all down to the main landing? Because that will impact the size and the capacity of the emergency power generator. We highlighted this down here for buildings that are not equipped with an emergency power generator. All elevators should be equipped with an elevator controller manufacturer's auxiliary power operating system that will, at a minimum, run the elevator to the next available landing. So that is a standard elevator system that's offered on, I'm going to go out on a limb and say all elevator controllers have this capability. And it's just, so that's a choice by the building owner, but this is the recommendation. So it really helps to prevent entrapment in the event of loss of building power. The hydraulic elevators will run down, but just by opening the control valve. Traction elevators will run to the next available landing depending on the path of least resistance. The load in the car will determine that. Dale, anything you want to add as we go along here, please jump in.
Okay.
So application of elevator types to facility design is 2-4. There's information in here for designers, for facility managers that are not familiar with elevators. I expect most of the people on this that are attending this webinar are familiar enough to know some of the stuff we're presenting here, which is the comment for hydraulic elevators should be considered for facilities of 2 to 4 stories. Once you get higher than 4 stories, the limitation with hydraulic elevators is speed. And typically with higher rise buildings, you have more traffic. The limitation of 150 feet per minute for hydraulic elevators just isn't going to cut it for providing effective movement of traffic in the building, vertical movement of traffic in the building. So that's why that limitation recommendation is there. You can see down here for electric traction elevators are the most appropriate for buildings of 5 stories and greater. Chapter 3, machine room, control room, and machinery space. An elevator machine room should be provided for each elevator or group of elevators. That is the opinion of the Elevator U Education Committee. And the reason for that is the elevator machine room provides a safe, secure, and effective working area for elevator maintenance, service, troubleshooting, and safety code certification, inspection, and testing that's required for the elevator for the service life of the building. So for the next 30 or 40 years, all of this goes on with maintaining and servicing and inspecting and testing the elevators. The elevator machine room provides a designated area, the only designated area in the building that can be used for storage of and access to, okay, it's not the only area that can, sorry. I should have mentioned in the first paragraph, the elevator machine room is the only designated area in the building that is available for work, maintenance, service, troubleshooting, and safety code certification, inspection, and testing. Now, the second half of that is the elevator machine room provides a designated area that can be used for the elevator design, maintenance, service, and inspection documentation that's required by ASME A17-1 to be retained and made accessible to elevator personnel at all times. So all of the check sheets, the logs that are required by the safety code to be filled out as the elevator contractor shows up to do the maintenance of the elevator, by having a machine room and having the documentation in the machine room, it really facilitates that effort. The next paragraph is elevator machine room location. I think all of us have seen elevator installations where the elevator is anywhere from 10 to 50 feet down the hall from the location of the elevator. The most effective, and that's what we're talking about here. What's the most, what is the, how can the building be designed to provide the most effective and efficient maintenance and service and inspection and testing of the elevators that were required to maintain and service and inspect for the life of the building. So this elevator machine room location, that first sentence, the elevator machine room should be located directly adjacent to the elevator hoistway. It's just common sense. If you see this note down here, this is missed a lot. There are a lot of people who are not familiar with this requirement. For buildings located in a flood zone, locate the machine room on the next highest floor level that is above flood zone elevations as determined by ASCE 24-05 flood resistant design and construction. This is a requirement in ASCE 24-05.
And that standard is required by A17-1.
So machine room access. For elevator safety code compliance, a clear access route must be provided from the building entrance to the elevator machine room. To facilitate safe and effective elevator maintenance, service, inspection, and testing for the service life of the building, the route should have a minimum width of 3 feet and a minimum height of 7 feet. The reason this is in here, and Dale and I were saying we probably shouldn't tell too many war stories because we won't be able to get through the document. But we had a new construction project that we showed up to do the acceptance, inspection, and testing and commissioning on, and the elevator machine room was in the basement of the building. This is a commercial building, and I showed up on the job. This is the first time I had been on the job, and went down the stairs to the basement with the construction manager to just look it over before we started inspection and testing. And in the path from the stairs to the elevator machine room was a duct that ran the full length of the basement of this building. It was 3 feet wide, probably 40 inches high. The bottom of the duct was I crawled under it, so it was about maybe 3 feet off the floor. There was no way to get that to that machine room without crawling under the duct and crawling out the other side and getting to the machine room. So the architect was on the job, and I said, this is not code compliant. This is not acceptable. The code requires safe and effective access to the machine room. And the architect agreed until the construction manager mentioned, well, sir, this is in your design. This is on you. This has to be corrected. And then he started arguing, well, it is safe and effective. All you have to do is bend over and just crawl under the ductwork and you're at the machine room. So it's really not a problem. So is this a code requirement, this 3 feet wide and a minimum height of 7 feet? No, it's not defined in the code, but it is a recommendation. It is for designers and for the facility manager to be aware that the code doesn't define it. So somehow this has to be defined. And so that's what we did in this guide. When we do our presentations, we usually have more time and we take questions and answers as we go along. So I'm hesitating, expecting a question, but we're waiting. We're going to get through this, and then we'll anything you have questions about, we can talk about. Elevator control room for building configurations where a machine room cannot be provided. A17-1 allows for the elevator controller to be installed in a control room and for the drive machine to be installed in the elevator machinery space. Where provided, the elevator control room should be designed for full bodily entry and sized to provide a secure and safe working area for, and this, I know I'm reiterating what we said about the machine room. If you're not going to have a machine room, if you're going to have a control room and a control space, this is still critical. Having a safe and secure working area for all the maintenance, service, troubleshooting, and safety code certification, inspection, and testing. So we talked about this already, the ASCE flood design. This is going to be, it applies to the control room as well as the machinery space. It has to be located above the flood resistant, the next highest floor level that is above flood zone elevations.
It does allow for elevation of the equipment in that room if the flood level, if it can be maintained the height of the room. So you don't have to go to the next floor if you can get it above the flood level.
3-3. Let me scroll up. So let's see. For building configurations where a machine room can't be provided, A17.1 allows for a machinery space. If a machinery space is used in the design of the building, it should be designed for full bodily entry, sized to provide safe and secure working area for all of the equipment, for the maintenance and service and troubleshooting, inspection, and testing. So that 80 inches is highlighted because Dale realized when we were going over this that we had put 7 feet, and the requirement is this is for the door into the machinery space access. It should have the minimum width of 3 feet and minimum height of 80 inches. Vertical ladders, ship ladders, alternating step tread designs should not be used for machinery space access. A standard stair should be provided. That is the safest, most effective. You have to keep in mind that the elevator mechanics and elevator inspectors are carrying tools and equipment and documentation, the paperwork that they need for performing testing and for recording testing and maintenance and service.
These stairs are allowed by 17.1 to be a 60-degree angle. In this requirement right here, it says 45 degrees. We've had several discussions with architects that would rather just design the stairway to be a standard stairway and not to have to deal with any different angles. So within the NAVFAC facilities, most of the designers use the standard 30-degree angles for normal stairways.
So elevator hoistway. Okay, so this is something that was going to be new to almost everybody who's attending the webinar. This is something that I was concerned about a decade ago or longer. Every mechanic, I would guess that every elevator mechanic and every elevator inspector, everyone I know and have talked to, has at some point in their career been stuck under an elevator, lying on the pit floor with the car either at the bottom landing or sitting on the buffers. When you're in that position, you start to think about all the things that could happen that could be really bad for your health and safety. And most of the people on this webinar know, if you think about a hydraulic elevator, and if you're lying on that floor and you're looking around all 4 sides of the elevator, there's no way to get out. we're talking clearances of anywhere from an inch to 6 or 7 inches, 8 inches, even 10 inches. You can't get out of there. This finally came to a head when we had one of our inspectors working in the pit of a hydraulic elevator, and the elevator controller caught fire. The hydraulic elevator lowered down to it just started coming down. He hit the floor. It came all the way down to where it was sitting on the buffer springs in the pit. And he was stuck under that elevator for 3, 4, 5 hours while the facility maintenance people tried to figure out how to get that elevator up so he could get out of the pit. At that point, I said, okay, we have to do something. So Dale and I started working on what do we need? We would stand ourselves up against the wall and hold a tape measure and measure, okay, how much room do we need? Absolute minimum to get out of that pit. And so that's where we came up with these clearances, and we put in the NAFAC and now the DOD criterion specifications require a minimum clearance on any one side of the elevator that will allow for emergency egress to get out of that pit in that kind of situation that I just described. So to minimize the risk of entrapment, the design and construction of new elevator hoistways should provide for a minimum horizontal clearance of 20 inches between the side of an elevator platform or cab and any one wall of the elevator hoistway.
The scenario that Kevin just mentioned, it was also lucky that the fire extinguisher was already installed in this machine room, and they were able to put the fire out with the fire extinguisher, and it didn't activate the sprinkler system. If the sprinkler system had activated, that inspector in the pit would have had all the water coming in there. And he did stay in there over 4 hours.
So this Hoistway Pit Ladder paragraph, the code says the ladder has to extend to 4 feet above the lowest landing. We see a lot of ladders where the side supports to the ladder go up to 4 feet, but the top rung might be 12 inches, 16 inches below the very top of the ladder. The whole purpose of that ladder is if you're in the pit and the hoistway doors are closed, well, it's for access and egress. But if you consider when you're trying to get out of the pit, the hoistway doors are closed, you have to climb up, hold on to the ladder with one hand and reach over and pull on the door lock and locking roller to open the hoistway door. Well, if you don't have a horizontal rung at 4 feet, that gets difficult and dangerous, because if you're holding on to the vertical side of the ladder, your body tends to swing away from the ladder as soon as you let go with your second hand. So the wording in here says the ladder should be designed with continuous rungs every 12 inches for the full height of the pit ladder, which means that there should be a rung at the very top of the ladder. It should be a rung at 4 feet above the sill. Everybody here should be familiar with the Hoistway Pit Sump and Sump pump. Dale and I were talking earlier, and he suggested that I highlight this number 3 under 4-1.3 because the code does not give a minimum weight bearing capacity for that grade. And often you'll go out and those and what's been provided will not support 300 pounds. Are the inspectors and mechanics 300 pounds? Not necessarily, but some of us are get close to that. So it's a good idea to have this in your spec to make sure that you have a well-designed and substantial grate over the sump.
I thought you were going to get personal there.
I said us. Everybody in here, I expect is familiar with. I didn't highlight this, but this is a requirement that before I leave this section, I wanted to mention. 50 gallons per minute. The code used to say per elevator. Now it says 50 gallon per minute per hoistway. But this is a requirement that everybody needs to be familiar with, that there is a capacity, a pumping capacity for the sump pump in the code. And that has changed from per elevator to per hoistway.
And the designers typically don't understand that that's not just the pump rating, but that's the actual discharge rate at whatever head pressure you have.
Kevin, we don't have any questions at this time, so if you want to expand on any of this, feel free.
Okay, we still have a couple more chapters to go. So we're at 10:30. So I'll just keep going until you tell me to stop for questions. Is that right?
That's correct. So
okay.
If anyone has questions, feel free to put them in the chat or the Q&A at the bottom.
So 4-2 hoistway lighting. Hoistway pit lighting must provide a minimum of 10-foot candles at the pit floor in all areas of the pit. That's, and then for safe and effective maintenance, so well, this is a code requirement. Hoistway pit lighting must be provided a minimum of 10-foot candles in all areas where maintenance has to be performed or may have to be performed in the elevator hoistway. Most of the certified inspectors that are here have probably had a difficult time enforcing or knowing how to or what to enforce or how to require. There's as many designs for hoistway lighting as there are not even just installation contractors, but as there are jobs. You go from job to job, it's all different. Most of the jobs are it's just really hard to get good hoistway lighting because in the past, all we had for hoistway lighting was a light bulb screwed into a light fixture on top of the car. Then the code changed and put in this requirement for 10-foot candles anywhere in the hoistway where maintenance and service may have to be performed on the elevator or in the elevator hoistway components. So our idea was to define how we believed what type of design would provide effective lighting without being onerous, without overloading the job, without causing it to be too expensive. What we determined over years of trying different systems and then measuring the lighting and talking to the building contractors is the following. For control, for a minimum of 2 fluorescent or LED lighting fixtures should be provided for lighting on the elevator of the elevator hoistway pit. The fixture should have one-piece molded high-impact clear acrylic diffuser with secure seal. And then a similar fixture should be provided a minimum of every 10 feet vertically up the hoistway. So for a single car, that could be these fixtures all the way up the hoistway. For a duplex, the same design works. You just put the fixtures in the center of the hoistway between the two cars and have these fixtures 10 feet up the hoistway. And it just provides outstanding lighting for all the work that has to be done in the hoistway then. And then the lighting control 4-2.1, 2 three-way switches should be provided inside the elevator hoistway at a height of 4 feet above the top and bottom elevator landings. So top landing, bottom landing, just inside the door, you have a three-way switch, and you can turn on the lighting for the pit and all the way up the hoistway. And it really facilitates effective maintenance and service and inspection and testing. Chapter 5, elevator systems and components. Now we're getting into the specification side. So this guide covers both design criteria and specifications. There has always been a healthy discussion about what really constitutes proprietary and non-proprietary equipment and systems. For our purposes with DoD, all of the equipment had to be non-proprietary, because all of the maintenance, the installation, maintenance, and service of elevators, all of those contracts had to be open and available to any and all service providers. And for any building owner, that's really what is in the best interest of the building owners, to be able to get competitive bids from as many service providers as possible. So this guide recommends non-proprietary equipment and then defines what the Elevator U Education Committee considers to be non-proprietary equipment. So 5-1.1 for the elevator hoist machine. This paragraph defines what we consider to be non-proprietary. Elevator hoist machine configuration and installation design should be mechanically and electrically interchangeable with a minimum of 3 other elevator manufacturers' hoist machines that are readily available in the elevator industry. If you have a problem with the machine over 15, 20 years down the road and you have to replace it, that gives you the flexibility of deciding what in the market is the best elevator machine that would be the best for the college or university. And this design would allow you to then choose from several different suppliers. Hoist machine should provide comprehensive factory training to include installation, adjustment, service, and maintenance. The elevator hoist machine should be identified as available for purchase and installation by any licensed elevator contractor. Only stranded steel wire rope should be used for elevator suspension and counterbalance. The reason for that is twofold. One is stranded steel wire rope is the standard. It is what is most available. It is the suspension means that's used. If you go back to number 1 here, hoist machine configuration and design, for most of the machines, it is stranded steel wire rope that is used on those machines. The second reason for that is down here in hoist machine characteristics. If you look at number 2, it's highlighted. The elevator hoist machine emergency brake should be designed to decelerate the car by acting directly on the elevator hoist ropes. Most of the elevator people in this, I'd say all the elevator people that are listening in and participating in this webinar know that one of the ways that an elevator can be out of control and moving up or down the hoistway after the drive machine has stopped and the drive shiv has stopped is by the hoist rope slipping traction. The elevator safety code, when the paragraph was prepared for the requirement for an emergency brake, specifically and deliberately, it specifically says it, the suspension will not be considered in the design and operation of the emergency brake. So it allows for an emergency brake to stop the shiv and not protect against the hoist rope slipping traction and the elevator flying up the hoistway and slamming into the overhead, or flying down the hoistway, or if it is heavily loaded and hitting the buffers in the pit. So by using an emergency brake that acts directly on the hoist ropes, even in the event that the car is moving uncontrolled through the hoistway as a result of slipping traction, this emergency brake will grab the ropes and bring the car to a sliding stop. Still no questions, Brad? Or comments?
Do not see any at this time, though.
The second characteristic we have in here is hoist motor should be designed and installed so that the motor amperage does not exceed nameplate motor amperage when the elevator is running in any direction or loading condition. So these are recommendations for getting an elevator installation that will provide effective performance and the longest useful, what's the term? Machine service life, sorry. Okay, non-proprietary elevator controller. Elevator manufacturers should provide comprehensive factory training to include installation, adjustment, service, and maintenance, and have that training available to any licensed elevator contractor. The elevator controller should be identified as available for purchase and installation by any licensed elevator contractor. The elevator controller manufacturer should provide a technical support phone service with live technical support available during standard working hours. That doesn't have to be free. They can charge for it, certainly, but it should be available to any licensed elevator contractor who is maintaining and servicing the equipment. These are the characteristics of the controller that the Elevator U Education Committee considers to be in the best interest of the colleges and universities. We have a recommendation in here for a machine room cabinet for storage of elevator and documentation and construction and wiring diagrams. A locking metal cabinet should be provided and secured to the wall of the machine room and sized large enough to accommodate all documentation and diagrams. So that says construction and wiring diagrams, but I thought we also included, I know we talked about including for the maintenance control program, there is a lot of documentation that should be in that elevator machine room. And anybody who has worked in an elevator machine room knows that there's no place to put it except on top of the controller, on the floor, or on top of the pump unit and hydraulic elevators. So by having a cabinet, you can secure the documentation. It's accessible when you need it, and it gives you a place to open up the documents and work on them by using the top of the cabinet. So just to comment in here about the permanent magnet gearless machines is a great equipment. Absolutely. The function, so high efficiency gearless elevator machines are available for use. The drive machine utilize electric motor design with permanent magnets to increase the energy efficiency. The functional design is similar to traditional gearless traction machines, and the machines can be located in an elevator machine room or in an elevator machinery space. Regenerative drive motor control has been developed for electric traction elevators and incorporated into elevator design. Uses energy that's developed when the elevator is running in an overhauling load condition, converts that mechanical energy into electric energy and feeds it back into the facility power grid. Here's the rub. Here's the recommendation for the designer and the building owner. Due to the high cost of regenerative drive systems, designers and building owners should conduct a cost-benefit analysis to determine if the energy savings will offset the higher cost of the regenerative drive motor control system. And in a lot of cases, it's absolutely a great system. In some cases, the savings don't justify the high cost of installing that system.
There are a couple of questions in here. I don't know if you can answer these, but
okay.
It says that many major elevator companies are using steel belt and aramid as main ropes. Will this be allowed in the future?
Are using aramid rope. This does not preclude. This doesn't say you're not allowed to use it. So that is a decision to be made by each individual facility, each college and university facility management professionals.
Yeah, these are just recommendations based on life cycle cost.
So absolutely, and every designer and every facility manager should look at the available technology, the available systems, and make that determination.
There are some people that are outside the United States that are asking some questions about the EN code. If a lit, which you may not know, but if a lift pit is more than 2.5 meters deep, is cat ladder allowed? Do you know that? Under the EN 8120, 50 access door is mandatory.
Well, the access doors are required for deep pits.
Yeah, and I think that's what he's saying. He's just putting an actual.
Yeah, a 2.5 meter pit is what, 8 feet, approximately 9 feet.
Yeah, about 8 feet, I think.
Yeah.
Yeah, if you have a pit that deep, you probably would have a regular walk-in access door, not a ladder. I mean, the code, I think, allows, it used to be 120 inches deep pit. I think it's 144 now.
So if the building design has a basement that the elevator doesn't go down to, absolutely, that's allowed by the code. That's not even addressed in this document. What's more typical is a pit with an access ladder. So that's, yes, nothing in here precludes the use of a walk-in pit. You have another one?
Or just talking about it, is there a talk to maybe follow, harmonize the codes with the N81, the A17? And I don't think that's.
It's kind of outside the scope
Yeah,
of
right.
this presentation, but I know that's going on. Yes, that's absolutely going on within, looking at doing that and how to do it and how to harmonize. But so will that come about? We'll see.
That's it.
There is a lot. I worked with EN81 20 some years ago doing inspections and testing in Italy at the Navy bases in Italy. And over the next 15 years, I saw tremendous improvement. EN81 did draw from the A17-1 and it drew from some of the other codes and standards, and E81 is a very effective document.
That's it for now. We've got about 8 minutes or so if you want to.
Okay. Any more questions or no?
No, that's it for now.
Okay. So 5-2.3, now we're talking about energy efficiency. Just a recommendation to use LED lighting and to use automatic shutoff. Elevator cab lighting should be equipped with automatic shutoff control system to turn the elevator cab lights off when there's no demand for elevator operation. Probably don't need to talk about the unlocking devices. This just says that the standard guide rail is the T-section rail, and should be used for elevators. Most of the guide systems and the safeties are designed for T-section rails. So the Hoistway Pit stop switch should be a push to stop type elevator stop switch. This is a critical safety device and a critical safety concern. Toggle stop switches can very easily be turned on accidentally. Now the code requires push-pull, but I don't think it says push to stop. So believe it or not, we went out on an elevator inspection and a contractor had installed a pull to stop switch. I had never seen that. I had never even dreamed that a stop, everyone thinks of a push-pull stop switch that you hit it to stop. But darn if there wasn't a pull to stop switch installed for the Hoistway Pit stop switch. So that's why this one in here. We talked about the Hoistway Pit entrapment protection area, the egress area. So in that area, since that will be used to extract personnel from the pit in that kind of emergency situation, or if someone's stuck down there and they're trying to get out by themselves because now it's Friday evening and they got stuck in the pit somehow by themselves. That's one thing I want to mention is for NAVFAC, we never allowed the inspectors to go out and do inspections by themselves. You should always be doing it with the contractor preferably the contractor, or if you don't have the contractor, 2 people, because we get ourselves into tenuous positions and situations. There should also always be somebody that you're working with. But this requires a stop switch in that egress, emergency egress area, or it recommends a stop switch. If someone's trying to get out of the pit and they're by themselves, they can hit that stop switch, remove power from the elevator controller, close, open that safety circuit, and then try to do whatever they need to do to get out. One of the things we recommend is an emergency lockbox for each elevator. Keyed lockbox should be provided at the firefighter's emergency operation designated landing. Flush mounted into the wall within 20 inches of the hoistway entrance assembly. A minimum size to be able to have the machine room key, the door lock key, and it should utilize the A171 firefighter's emergency operation key for the lockbox itself. We recommend roller guides for all elevators. With slide guides, you have lubricants that have to be used. It's just one of the things that we're continually thinking about when we go over the criterion specs is minimizing the requirements for maintenance. So with roller guides, you don't have the requirements for making sure that the hoist, the guide, the rails are lubricated, cleaning up the lube in the pit. So there's a requirement, a recommendation for roller guides there. We recommend a downspeed regulated control valve for hydraulic elevators. That with that type of control valve, the elevator will run at its rated speed, regardless in the down direction, regardless of the load on the car. So you have uniform car speed with the downspeed regulated control valve.
It increases the efficiency.
Overspeed safety valve for every hydraulic elevator. The cost of the valve and the installation of valve is the safety provided by the overspeed safety valve outweighs the cost of the equipment and the installation of the valve for the life of the elevator. This talks about cylinder protection. I'm pretty sure everyone listening is familiar with. One of the things is a casing, steel drive casing with a welded steel bottom I think is in here. That the PVC liner would go down inside the casing. Over years of contractors trying to seal the bottom of a drive casing that doesn't have a welded steel bottom, over time, the concrete that they would drop down into the bottom of the casing to try and seal it would fail, and the drive casing would fill up with water. So that's why we went to a welded bottom on a steel drive casing. I don't see that in here. That's exceptions. I'm curious now.
Yeah, it was in there.
Here, a dry plumb steel well casing should be provided for every in-ground cylinder assembly. Well casing must be located according to the well casing should have a minimum 1/4 inch thick wall and a welded 1/2 inch thick steel bottom. That's not going to leak for a very long time. How are we doing for time, Brad?
We're right at 10 o'clock. I don't know if you, I mean, we could extend it a couple of minutes if you're almost finished there.
So we've really completed the specs and criteria. This just talks about operation and maintenance data packages, wiring diagrams, maintenance control program. I mean, that's everyone should be familiar with a maintenance control program, but A17-1 requires an MCP program to be prepared for each individual elevator and escalator. It has to be provided and on the job site prior to beginning the acceptance inspection and testing. I shouldn't say every time, but usually when we go out for an acceptance test, there's no maintenance control program. Even when we've identified that as a safety code requirement when we look at the contractor's elevator package submittal, the code requires it to be available prior to acceptance inspection and testing. Commissioning, performing. So that's pretty much it. I mean, we covered the whole document.
There was one quick question. I'll see if I can. It says rails do rust when using roller guides. Does dust accumulation on the rail increase the wear of rollers? What is your opinion? Do you know?
That would have to be a lot of dust and accumulation.
Okay.
Stuff. So
rust will because of the pitting of the steel. But if you have rust on a traction elevator rails, it's going to affect the safeties also. So that's a safety hazard.
So the bottom line is that should be addressed by the service provider.
Well, Kevin and Dale, I'd like to thank y'all today for doing this presentation. It looks great. It will be available to our members on our website when we can get that posted, hopefully soon. And if you would, if someone was interested in your services, how could they get in touch with you?
We have a website, www.elevatorlogic.com, and we have it tells you about our experience, the services we provide, and has a telephone number and the ability to send us an email.
Right. Well, again, thank you for doing the presentation. And thank you to everyone for joining and the questions and the interest. And we plan to have some more webinars in the future. So just stay posted and keep looking out for the Elevator U newsletter. Thank you, everyone.